Welcome to the Cold Steel Surgical Podcast with your hosts Amir Farouk and Chad Ball.
Cold Steel family, I had a hard time thinking about how to introduce the guest for this episode. Dr. Teresa Purzner is a neurosurgeon here at Queen's University, but it's really hard to encapsulate all the things that she's done. She had developed a baby cereal formula while she was doing her PhD. She obviously has done a PhD and developed a drug and also developed a way to take it to market. And this drug can potentially cure a specific type of pediatric brain cancer. Since coming on staff at Queen's University, she has gone on to completely revamp and redesign the way that patients with brain tumors are triaged, dealt with, and diagnosed with spectacular results. I think that's the biggest thing that stood out for us from this episode was simply that when Dr. Purzner sees a problem, she just goes after it. And it really inspired us to think about the ways that we can look around our environment and when we see problems, just go ahead and take them on and look for ways to solve them. You'll love Dr. Purzner's thoughts on how to do science, the role of science in surgeon's life, and her thoughts on entrepreneurship and design thinking, specifically as it relates to healthcare. You won't want to miss this. Stay tuned. Dr. Purzner, thank you very much for joining us on the Cool Steel podcast. It's an absolute pleasure and an honor to have a colleague join us on the podcast. Not just a colleague, but an entrepreneur, a basic scientist, neurosurgeon extraordinaire. Like, what other epithets can we use to describe you? Just thank you so much for joining us.
Well, what is mom? the most important title.
Absolutely. There you go. Can you tell us a little bit about where you grew up and where you did your training?
Sure. Yeah. So I grew up in Scarborough, Ontario. I went to public school out in Scarborough, and then I did my undergrad at U of T. I left after 3 years and then did my med school in London at Western. So I don't actually have an undergrad degree. From London, I went back to Toronto to do my neurosurgical residency and left halfway through the residency to do my PhD down at Stanford, and then came back, finished my residency in Toronto, and then ended up here at Queen's.
When you say you stopped midway through, was that a planned thing that everyone does neurosurgery at Western, or was that something that you chose to do?
Yeah, so the residency was in Toronto, and it's at the time I would say it was a lot more common, and there still is a good number of residents who will pause at PGY4 and go out to do research. At the time, quite a few were doing PhDs. Now there's a little bit more variation, but it wasn't uncommon in Toronto. But it is a fairly uncommon thing to do overall, I'd say, to leave a neurosurgical residency or any surgical residency to take on a full PhD. And for us, Jamie's my husband, and we've done all of our training together from med school onwards. For us, we were gone for, I think, 6.5 years. So it really was a fully immersive, very serious PhD that extended the training. So yeah, you end up being, close to 40 when you get your first job.
It's a long road, but clearly something that you've turned into some amazing products. And this was in Stanford, correct? Where you went to do your PhD?
Yeah, that's right. Yeah.
So tell us a little bit about that experience of going down to Stanford to do your PhD. Because, my impression looking through where you were doing your PhD is that this was like an amazing, very interdisciplinary kind of place. So what was that experience like? And how did you sort of find that lab or that area where you went to do your research?
Yeah, so we actually weren't looking to go to Stanford at all. We were looking to join a lab that was most in line with what we wanted to do, right? And so I was fascinated by pediatric brain cancer. And there's sort of two reasons. One is that it's just a devastating disease. And anyone who's had to reveal that type of news to a family, it's as crushing as you would think it would be, right? So it's this disease that's just horrific in terms of the outcome. The treatments that we have are effective, but because these are young children, their brains are still actively growing, the consequence of the treatment itself is really severe, right? They end up with cognitive deficits, endocrine issues, and stuff like that. And so for me, the disease was horrible, but the pathophysiology of the disease was actually extremely well understood, right? So we knew that in adult brain cancer, there's hundreds of different mutations that are different between people and over time, and it's a really, really challenging cancer to fight. But with the most common pediatric brain cancer, we knew it came from the sort of developmental origin where there was a cell in the cerebellum part of the brain that would normally grow, and in normal development grows and it stops growing and it becomes the cerebellum. And in the cancerous state, that same cell grows and it continues to grow and ultimately gives you a tumor. And so for me, there was this huge gap between the elegance of our understanding of the science and the limitations in the therapies we were providing. And so there was this strong goal for Jamie and I to try to find a way of bridging that gap. And so we had a very systematic approach. We looked at every single lab in North America unbiased. We didn't care where it was or, just what was the lab, what had they done, how successful were their students, what were the profs like. And then we just cold called all the ones that seemed like a good match. There's a lot. There ended up being about 10 that seemed like a good match that were interested in seeing us. And so we spent 1 week in residency just flying from city to city, meeting these 10 people. And at the end of it, we really, really liked this one scientist, Matt Scott. And he was the one who sort of originally found the connection between brain development and this tumor. And so we decided to work with him, and he just happened to be at Stanford. And so it was kind of, we were never intending to go to Stanford. We were intending to work with Matt Scott, and he happened to be at Stanford. But that being said, I mean, I'm so, so glad that I got to experience Stanford, because it was just an incredibly immersive place that was so highly interdisciplinary and so adept at translational science, right? So not just doing really, really high interdisciplinary science, but also then getting those scientific discoveries and supporting them through to translation. It was an unbelievable experience. I was with the Biox program, and I'm actually going back to Stanford in a few weeks to give a talk to the Biox students about just how impactful that interdisciplinary and translational mindset has been on my early career.
One of the things that I have picked up on is the very sort of deliberate way you, and it sounds like Jamie as well, have asked the questions. Because I think, and Moraz Mead, who's a friend of the podcast and someone we've had on as a guest on the show a couple of times, and actually came last year as well to give us a talk at Queens. One of the things he always talks about is, a lot of times people spend all this time and energy on whatever their project is, or research project, but a lot of times they don't spend a lot of time thinking about the right question to ask, or they don't spend enough time like actually deciding how they're going to go about tackling something. Like they just decide, okay, this is this, I'm going to do this, and I'll just throw myself into it. And this story that you're saying about actually having spent all this time deciding where you were going to go. Like most people would just apply to a bunch of prestigious places and be like, oh, I got accepted to Stanford. Okay, great. I'm going to Stanford or wherever, right? But you actually called all these places and tried to figure out what would be the best match for what you were trying to do, right? That's a very different approach that I think the vast majority of people take when they're doing research or any kind of project. Is that something that always kind of came intentionally to you or naturally to you? Or is that something you've developed over time, sort of this, and we're going to get to this more in a bit, but this sort of design thinking, starting with the question in mind kind of approach?
I've always been very intentional in making the big decisions in life. And so I would say 90% of the decisions that I make day to day are relatively inconsequential. There's no long-term impact. And I don't give those questions a lot of thought. I kind of just go with the flow. But for things like, especially this question of where am I going to do my PhD, it wasn't just where am I going to do my PhD? It was also the fact that I am already going to be a neurosurgeon. And there is a lot you give back to the world as a neurosurgeon. And so if I'm going to take away from neurosurgery and put it towards science, it better darn well be worth it. I better be providing something that is so important and unique that it's worth not doing neurosurgery some days to do science instead. And so for me, the goal was I need to be a really good scientist. And I was passionate about this question. And honestly, I can honestly say it took as long to learn to be a scientist, a good scientist. I wish I hopefully will see TBD, but hopefully I will be as I continue to develop in my career, as it took to learn to do surgery. And the fundamental skill of the scientist is exactly what you said. It's how do you ask good questions, right? And what is a good question? It's more than one thing. First of all, it has to be interesting, right? For me, it has to have a translational significance, right? So if I'm right in my question, then this is how it's going to impact the patients that I care for. But I think that part's not necessary. I think there's a lot of really good science. Like CRISPR was developed by something that was pure science, right? It wasn't for translational potential. And it's one of the great innovations of our time, right? But for me, I always like that translation one. So it has to be a unique, interesting question that if answered is going to impact my patients. And it has to be feasible, right? So you can have great questions, but if you don't have a feasible way of answering that question and an efficient way of answering that question, then your question is not a very good scientific question. And so it really took me, 6.5 years to learn how to narrow in on questions that are not just interesting and important, but also that I can answer reasonably within the limited resources that I have. And that's a very hard skill. You learn it partly just from the hard knocks of the science. You put all this time and effort into a question and you end up being wrong. And you learn, oh, I shouldn't be asking questions that have a yes or no answer, where if the answer is no, I have nothing. And so developing questions where no matter what the answer is, whether it's yes or no, you still learn something interesting that contributes to the scientific, literature, I think is important. And a lot of it was just being trained by exceptionally good scientists who just keep you on the straight and narrow and say, no, this is the reason why your question is not good. This is the reason why your approach is inefficient. It comes down to a question and then followed by, I don't know if you've ever played that game, the 20 questions game, where you're trying to think of, I'm thinking of an animal, right? How to most efficiently get to what is that animal? Asking the fewest number of questions possible. And so that's sort of how I design my experiments too. What are the least number of experiments that I can do that either proves or disproves the question that I'm asking? And to me, both are equally important. If I can disprove my super exciting question in 3 experiments, I'm going to do that because it's going to save me the 20 experiments it would take to prove it. And so that skill of asking a good testable question that to me is science. And that's what took so long to do. The techniques and stuff, like you said, we're surgeons. We can pick up techniques. We can YouTube our way through almost anything, right? Whether it's like home repairs or I'm building, my daughter wants to be this K-pop demon hunter for Halloween. So I had to build this cosplay wig. And so, how do you make a cosplay wig with a big thing? We have learned to be extremely efficient at picking up skills. But the skill of asking good questions, you can't YouTube your way through that. You have to be trained into that. And that really is what my time at Stanford taught me, was how do I do this? And then the second big thing, which to me is pretty separate from science, is then how do you bridge that discovery into something that's functional for the people you're trying to help?
Such a profound way of putting the work and learning how to ask good questions. I'm really curious for residents who are interested in doing research. And this is kind of a bigger global problem, right? Like there's all this sort of academic bloat, right? That now accompanies even medical students, not just residents, but like even medical students now there's all these expectations of them having done some research or having something on their CV to then show that they're going to be a good candidate for residency. And the same thing for surgical residents. And I think as a result, people end up doing research that they're not passionate about. They don't actually learn how to ask the questions the way that you clearly have learned to do it. And it sounds like from your experience, the only really good way to do that is to be with fantastic mentors that'll force you to think and really force you to improve the way that you think. I'm curious what your thoughts are for people who are or are not interested in doing research during residency. How do you sort of decide, is research a thing that's going to be worthwhile for me to do?
I agree with you. I think there's this pressure for people to be academic. And I strongly disagree with that pressure. I don't think you have to be a researcher. I think you're already a physician. And if you're a surgeon, you're already a surgeon. And you can contribute so much to the world by being really good at your job, right? Science, maybe you'll make an impact, maybe you won't. Who knows, right? But as a doctor, every single day you're operating on someone. If you're doing the best possible job that you can, you have helped that person. And you can point to that person and say, that is one person whose life is better because I was part of it, right? In science, it's a lot more nebulous, right? In science, like I love science for so many reasons that we can go into later, but they're very personal, right? I just like it. I like doing puzzles. I think science is a big puzzle. I love discovering things. But if you don't have that and you don't love that, which is extremely reasonable, but you do love surgery, then you should become a really, really good technical surgeon, and you will contribute so much to the world, so much more than you will as someone who doesn't really care about science, but has to do it because, that's the expectation. And I mean, of course, there's the realities of the world where you need to get a job and maybe you need some papers and this and that. And if that's the case, then I would spend the least amount of time you need possible to get those papers out to get the job. But focus on what you love and focus on what you're doing. And as a doctor, it's just so easy to justify why what you're doing is important because the impact is it's so immediate. So I don't know if that answers the question, but that's what I would say. Do what you love and do it really well, especially as a physician. It's unambiguous that you will provide so much good for the world as a result of having done that. Sometimes you have to play the game a little bit, spend the least amount of time possible to get what you need to do the thing that you're really, really good and passionate about.
This is the Teresa Purzner approach. Like, what do I need to do? How do I answer this question in the least number of experiments, right? I love it.
Yeah, exactly. Yeah.
I would be remiss if I didn't ask a little bit about the actual research work that you do with regards to glioblastoma and the experimental drug that you actually were able to develop. Maybe you can explain to this humble colorectal surgeon a little bit about the work that you do, and specifically about the work that you've done with pediatric glioblastoma.
I make decisions very deliberately, but I'm also pretty flexible with what comes next, right? And so I went to Stanford really again to do science. And I would say I kind of came with, throughout my training at U of T and Western, there was almost a sense of the purity of science, where as the scientists, you do the science, and then drug companies do things like developing drugs. But there was almost a sense that if you go into that world, then you almost tarnish the purity of the science that you're doing. And so I kind of went to Stanford initially with that attitude, let's do good science. And I took this really cool interdisciplinary approach where I was using this new mass spec technology to look at changes in proteins during brain development. Anyway, long story short, I ultimately found this one drug target that when I targeted it in the most aggressive forms of this pediatric brain cancer, medulloblastoma, it was resulting in long-term remission in over half my mice that were otherwise dying in 20 days. And so, the science led to this small molecule that worked, and it was really exciting. Every day you go in and you see these mice and they're still alive, and month after month. And I think we went out to like 100 days or something. There they are. And so every morning I would be happy going down to the animal colony and seeing my nice healthy mice, and the control group had all died months ago, kind of thing. So it was awesome. And I think that's normally where the story would have ended, just the publication associated with that. And that's where Stanford kind of came in, where I had this great result. It was working. My justification for coming to Stanford was to try to find a new drug that bridged the science to the patient. And there's a part of me that's like, okay, well, now I've done it, but really that's just it. And so I thought, again, you do this good science, you find this great drug, then a drug company swoops in and takes your discovery and makes it into, a human-ready therapy. But that's just it's not at all the way it works, right? And it became pretty clear, especially when you're dealing with kids. In kids, the diseases are rare enough. They're called orphan diseases, right? And so there's not a huge market for it. And so it's not a profitable disease to go after for the most part. There's some things that are being done, like the, creating hope vouchers and stuff like that to help give some compensation, but it's not like it's Lipitor, or it's not like it's, the GLP-1 inhibitors kind of thing. It's not something that financially really makes sense to pursue. And so it became clear to me that it wasn't going to happen unless I did it myself. And so I joined one of the programs at Stanford called Spark, and it's intentionally made to help people bridge this discovery to patients. And we just started going after it, just really doggedly. Things like, what is the IP? Deciding if we were going to make our own drug or work with a startup that had a human safe but never before really applied in phase 2 studies inhibitor. And then so we decided to work with the startup, and then dealing with them, how to get them engaged, how to make them agree to give their drug to a child, which compromises, their other tracks if a kid gets sick, working with regulatory and with trial design, and then ultimately working with the Pediatric Brain Tumor Consortium, which is just this incredible consortium that was able to help us negotiate with the drug company and ultimately bring it to kids. And so we were able to go through all the many steps and finally get it to kids. But that to me was not science at all. That is a lot more like entrepreneurship, actually, where it's just this dogged, unrelenting tenacity and convincing people one person at a time that this makes sense. And so that's how it happened. But I have to say the chance of bridging that gap between science and person, it's a tiny percent of drugs that actually get into a human. And those stats seem really overwhelming. It's like, if you go all the way, maybe less than 1% of these drugs are going to get there. And so it really taught me that these things that seem insurmountable, that seem impossible, before accepting the fact that it's not possible, that you need the $100 billion of a drug company to do this, there's no way, little old grad student can sort of champion this. rather than just accepting the fact that it's not possible, taking the time to speak to experts to say, okay, what are the actual steps involved in bridging this gap? And is there any one step there that is impossible? And what became clear to me is that every step was really challenging and the odds were against me, but there was no one step where I said, you know what, that's not possible. And so that's how we went down that route. But it was a really strong learning experience that truly things that are statistically extremely unlikely, sometimes they're just unlikely because it's 20 steps and every step has bad odds, but no one step has impossible odds. And then the cumulative probability just goes down as you add each by each. But yeah, it was a pretty incredible experience. And in that sense, I have so much appreciation for, the physicians, medicinal chemists, the lawyers, the regulatory people, the entrepreneurs that sort of stepped out to help me bridge that gap.
It's an incredible story. And I love this idea of looking at a series of steps and deciding, is there any one step here that's impossible? No, it's just improbable. So I'm just going to go after it and do it. I love that.
Yeah.
That's fantastic. So I don't know if all the listeners know this, but you also started a baby food company. Was that at the same time before you went to Stanford? After?
No, that was while I was there. So that's another thing. Again, very. It was another thing that kind of just. It wasn't planned. I did not go to Stanford saying I'm going to learn entrepreneurship, right? I was there to do science, and what happened? It's almost like it's toucan Sam. I just follow my nose, and sometimes it leads me weird places. But so I was there, and I had my kids. So I had all three kids when I was doing my PhD. And what became really clear to me after the first kid was the nutritional deficiencies of what was shelf-stable baby food at the time, right? And so, I approached my child as a mother, but also with this undeniable understanding of early brain development, right? And I really appreciated that, I can probably mess up almost anything and get it right later on. And there's this buffer where ultimately I can, make things okay. But the one thing you cannot mess up early on is those first sort of 1,000 days, they say, but the first couple of years of brain development, because that's a really unique phase in human development where the brain is actually growing, right? Most of your cells, as you know, especially with the GI, there's turnover in the cells, right? And they continue to turn over. You get cut, your skin heals, you break a bone, it fuses, right? But with the brain, all of the development happens in those first 18 to 24 months. And after that, that's it. Those are all the brain cells you get. There's little exceptions, cerebellum is a little bit, hippocampus a little bit. But overall, the great majority of your brain just happens in that first stage. And then the rest of your life is creating synapses and pruning synapses. And that's how, that's learning and memory. So I really wanted to get that right. I wanted to make sure I create the perfect milieu so that all of them could reach basically their genetic potential, right? And there was three variables that go into how well that brain develops. One is just the genetics. It's the parents is what it is, and meiosis. And then the second thing is the environment, right? So interacting with the child, reading them books, giving them the right toys, tummy time. And then the third was nutrition. And of the three, the one that at least I really knew very little about was nutrition, right? I didn't learn about nutrition very much in medical school. I had no background. And so I did, the surgical way. I just started reading, going after it. And I almost used it like a scientific, I basically did a lit review on what is the nutritional impact of early brain development. And there's actually, I was surprised, really good basic neuroscience, right? So nutritional science can sometimes be a little bit correlative. Eggs are good, eggs are bad. Eggs feed them at 6 months, feed them at 8 months, feed them at 4 months. But there was actually hardcore developmental neurobiology looking at the nutritional impact of specific nutrients on specific brain regions, right? And it became very clear that different nutrients are important for different brain regions. And as you probably know, in those first year and a half, the brain's not just growing as a big blob. There's parts that are growing at different time periods. And that's why the kid hits different milestones, right? They can't talk. And then you have this sort of ballooning of speech, right? And they can't walk and suddenly now they're starting to get up. And so it's not this linear thing. They have these little sprouts. And that's just a reflection of that part of the brain growing during that part of their development, right? And so I took all the literature on which region's growing at which time, and I took all the literature on which nutrients are important for what region, and then I made a meal plan so that each month, and based on the kids, they were getting exactly the nutrients they needed. And so you can imagine I was quite busy. And so I tried to just hack my way through it by going to the store and just picking out the baby food pouches that had the right nutrients. And what became unfortunately very obvious to me at the time, it's gotten a lot better, but at the time, none of the baby packs had like any of the nutrients, right? There was about 18 that I wanted. And I could maybe find like 2 or 3, maybe 4 in all of the packs, not like per pack. They just didn't cover things because most things were apple, pear, and banana, right? And so then I had to cook for myself. And I had to cook these kids' meals myself. So, I'm getting up, 4:35 in the morning, making these ridiculous meals for the kids because I really thought it was important. And then ultimately from that, my brother had a kid around the same time. And so I told him what I was doing. And he has one of these amazing wives that actually, do it all kind of thing. So she started cooking. And my brother, he's in finance out in New York. And he said, well, you should make this more available to other kids, right? We should make a company around this. And at first I actually said, like, there's no way, right? Like I didn't come to Stanford to make baby food. I came to Stanford to try to find a transformative therapy for brain cancer. I'm busy. I don't have time. But, it's my older brother. Older brothers know how to wear down little sister. So he wore me down. And there's actually, like, I talk about this in some of the other interviews I've done, but it's actually true. There was a specific moment, and I remember it, when I decided that I would actually do it. And it was when I was out at Whole Foods and I had seen another young couple with a baby, and they were in the baby food aisle and they were looking at all these pouches, and it must have been their first kid because they were super stressed and cared a lot. Right. And so they were looking so carefully, and they were trying to pick, which pouch is the one I should get. And I knew, because I had gone to the same place and looked through the same pouches, that no matter what they picked, no matter how much they wanted to make the right choice, it just wasn't there. And in fact, like all the options were bad. And so it was almost like the drug where you're like, oh man, I have this answer. It's important. There's literally not going to be any other neurosurgeon, neuroscientist mom looking to make a baby food company. Like it's me or no one, right? And if I don't do it, it won't be done. And I actually do think it's important. It's important enough that I'm waking up, at the early hours in the morning. And so I should probably do this. And so I started off just going to an entrepreneurship course at Stanford. I just walked in on pitch day and said, here's my pitch. And then some grad students, some GSB students, business students said, oh, that sounds pretty cool. Let's do this. So it started off as just a course. But at the end of the course, the Professor Rohan, and the main advisor, Brent Knudsen, they're just awesome. They said, well, this is actually pretty cool. If you want, let's build an actual team and company around this and see what happens. And so we did that. And then at each stage, I'm like, well, okay, this is probably the last stage we're going to get to, but it kind of succeeded. And then the next one, okay, so this is probably, they succeeded, and we raised money, and we had an incredible, team to start off the company, just absolutely incredible. And then we were going to launch online, but then Whole Foods came and said, hey, we'll launch you nationwide. And so we launched actually nationwide with Whole Foods. And then Target and Walmart came, and they're like, hey, this looks pretty cool. And so it just became, and Walgreens and blah, blah, blah. And so we became this behemoth of a company. And for a lot of it's just the awesome team I had. But I have to say, a lot of it was also just the actual retailers coming to us saying, hey, this looks really cool. I like what you're doing. We want to take this on. And so it just grew and grew and grew. And now I think we're in like 14,000 stores or something. We're massive. But again, it was this idea that this impossible thing with improbable steps, and it kind of just kept working out. And so, yeah, that's, well, I mean, the team, there's nothing about working out entrepreneurship. Like there's a tremendous amount of passion and grit and hard work. But even with that, you fail often. And so, there's also a good amount of luck too. But that's how it came to be. Yeah.
I need to understand a little bit about the early brain development of Teresa Purzner. So most people, when they see a problem, there was this gap where you said, okay, there's nothing out there. I know I have all this knowledge. There's nothing here that's can satisfy what I need. I'm going to go do something about it. Were you always like that? Was there something that your parents instilled in you that I see this problem, I'm going to fix it? Most people would say, oh, there's this problem. There's nothing I can do about it. Or they kind of, I don't know if this is a learned behavior for all the rest of us, that we kind of develop this attitude. But seriously, like, you see a problem and you say, well, I can do something about this. And I believe strongly enough about this that I can fix it. This is a deep, question that I'm asking. But I don't know if you have any thoughts about why Teresa Purzner looks at a problem and then goes and fixes it, whereas the rest of us sort of just throw our hands up and whine about it.
I think you're making me a better person than I am. I think you're making me a better person. I think it is that. Here's a problem. If I'm the only person that can fix it, I should do it. So I think it's always been the case from very early on, that if I saw someone who really needed help And I felt that I was the only one in that position that could help them. I think it's always been in me it's just a personality trait that I want to help that person. I want to alleviate suffering. I want people to understand the joys of life that I've experienced. And that was a big reason I became a doctor, actually, was I find a lot of enjoyment in helping others. But I think I think a lot of people are like that. I'm sure you're like that. And I think a lot of doctors that I've known are like that. They just genuinely get gratification out of helping people and and alleviating pain and suffering. I think what's a bit different, that I've always been a bit different, is I've had this sort of let's see what happens type attitude. And so I've always been very open to things and just seeing, let's just give it a go and see what happens. And if it doesn't work, it doesn't work. And if it does, it does, kind of thing. And so I think even growing up, I think of, my high school years, and I don't know how much I can talk about this on a podcast, but here's an example. My boyfriend rode motorcycles and I was on the back of his motorcycle and I was like, I don't like the fact that this feels unsafe and he's in control, right? And so I'm like, okay, well then I'll just get my own motorcycle. And so then I started riding motorcycles because that was the safer decision, right? It was better to do that than it was not to. And similarly, I got into marksmanship when I was young, not because I saw myself as someone who loves guns or anything like that, but because I enjoyed the serenity of the focus of getting something right into a target. I've actually never gone hunting, but right on a target. And it was an unusual thing to do to someone who was, like a straight A student. I was, a very accomplished pianist as well. That was sort of, but it seemed kind of interesting. So I thought, I kind of want to try that and see what happens. And I enjoyed it, right? And so I think I've always been someone who has I've never felt a need to fit a mold or to be a certain person, or if I'm a concert pianist and I'm a good student, then I should also be great at chess, right? Like I do exactly what kind of seems interesting to me. I like adventures and I'm not limited by the fact that, that's a bit of a weird thing for someone like you to do. It's just, well, if it looks interesting, I'm going to do it. And there's nothing about me that should dictate what I do next. It's the environment around me and what's most interesting at the time that dictates what I do next. And so I think that attitude of let's see what happens is sort of what has drawn me into these things as well. It's like, seems kind of cool. Let's just see. Like, I don't mind failing. I think that's another big thing too, is that if I try all this stuff and it doesn't go well, okay, well then I tried and I learned some stuff and it didn't go well. Let's try the next thing, right? So I've never been someone who was concerned about looking silly or foolish or failing at stuff. I just think failure is just, it means there's one less thing on my plate. Now time to focus on the next thing.
I love that. Listen, I'm very cognizant of your time, but I have to ask you a little bit to talk a little bit about design thinking and specifically how you applied that to the program here at Queen's with regards to brain tumors. Can you tell our listeners a little bit about, first of all, what design thinking is, and then secondly, how you applied that to brain tumors here at KHSC?
Yeah, it's a great question. So design thinking, it's a way of tackling a problem or an unmet need that's often employed in entrepreneurship, but it can be applied kind of everywhere. I learned it through the lens of entrepreneurship. And really, it's this very human-centric, rapidly adaptive approach to creating products or solutions, right? It has 5 stages. So you start off with empathizing, and it's the most important stage. When you actually go out and you talk to the people who are going to use your product, you get to know them really well. And you understand what is their impression of what they need from this product, right? So it's very much not, I'm going in with a hypothesis, right? So in science, you have a hypothesis, you think you have a guess, you go out, you test the guess and you see if you're right or wrong. Design thinking is the opposite. You start with a solution. You say, I want to make the best possible, let's say, travel app, right? And then you say, I have no idea what a travel app for traveling with families looks like, right? But I'm going to go and talk to 100 families who travel and say, you tell me what this app would look like. And maybe they say, I want to know what restaurants have kids meals. I want to know what hotels have cots. I want to know what flights allow lap child, this and that kind of thing. And then you design a prototype based on that feedback. And then you go and you test that prototype and you get feedback from that prototype. So it's circuitous. So based on the prototype that you created and you've now launched, you launch it in a way where you're constantly getting feedback from the users. And based on the feedback you go, that's basically the next empathize stage of the cycle. You get now the feedback and then you iterate and you iterate and you iterate. And so what happened in Southeastern Ontario is, quite frankly, we had some of the worst statistics in the province when it came to our outcomes with patients and brain tumors. So when I first got here, we were real outliers, over 100% worse than provincial averages in some of the metrics. And so it was just such this behemoth of a problem again. And the Canadian healthcare system is not easy to fix. And Queens is not particularly agile when it comes to creating massive systemic change. I would say very few academic hospitals are. And so I sort of thought about, how do we improve things in a way that happens quickly and is sustainable and actually works? And that's when I thought, this problem is a lot less science. It's actually a lot less traditional QI. This is a startup problem. We have to create a program, and the product is the program that rapidly creates change in a way that people actually want, right? And so I said that to me is entrepreneurship. And so I created a brain tumor program the same way that you would create a company around a product with a design thinking approach. And so we started off with the empathize. Again, I use sort of entrepreneurial techniques of primary and secondary market research, this idea that you talk to your customers, but you also see what's best in class. And based on that, we came up with a mission, a vision. I actually re-engaged with the previous CMO of Cerebelli, Kelly. She's awesome. And she helped us with creating a brand book, so color palette, logos, tone, voice, social media, legacy media. So we created like a company, and we called it the Queen's Brain Tumor Program initially. And then we started to create prototypes on interventions that we could do that would help patients. And we created those prototypes by talking to, I think it was 34 different people, right? Include everyone along the line of care, from the physicians to allied health, psychosocial, to patients and their families, and primary care physicians, hospitalists, emerge docs, everyone, to say, what is the problem right now? What do we need to do to solve it? And then here are the prototypes that we're thinking of implementing. Do they make sense in the context of what your day-to-day job is? Is this helpful to you? Or do we just think it's helpful to you and it's going to create more work, right? Which is, I would say, a lot of things and a lot of improvements that I have to employ end up being more work than help, right? Because they miss the target, right? And so we made sure that every intervention we did was approved by the people who would be doing the intervention. Otherwise, we just cut the intervention altogether. If we came in, we said, this is what we want, this is how we're going to add to the referral system. And the referrer says, well, that's going to create more work. It's an extra sheet of paper. We just don't do it because it doesn't make sense, right? And in that approach, we created sort of this program, and launched the program like a company. We actually launched it. We did a media push, and then we went out, we met with all the referring hospitals. We introduced them to the program. And then because, again, we had approached it like a company, we had, key performance indexes, right? So we had metrics that we were collecting going forward to seeing, is this working? And is each intervention working? And if there were signs that something wasn't working, we hear about it, right away. And we could either iterate on that intervention, or we could just cut it out altogether. And, we were a little more than a year in, but we have our first year stats back, and they're exceptional, right? It worked really, really well. So we went from, outliers to now, we're the top performers in the province for getting MRIs on time. 3 of the past 4 quarters were the top in the province for getting patients to surgery in time. And our 90-day mortality went down very significantly, about 8%, which is,
Wow, that's
really
crazy.
better than any therapeutic intervention for glioblastoma in a long time, right? Our overall survival increased. And something that's really cool is that during the empathize stage, we noticed that our rural patients were doing really significantly worse than our urban patients. We didn't actually do any interventions that addressed that directly. The intervention was just making the whole system better. There was nothing rural focused in this first round. In the second round, there is. But we actually, we took away that gap. So the gap in time to therapy, the gap in survival between rural and urban got completely nullified. And so now our rural patients do as well as our urban patients. And in some cases, in some metrics, they're doing non-statistically significantly better, right? So at least the trend is in their favor. So it was it was kind of a wild idea. It was one of those, let's see what happens type things. We can't really make things worse. And it really worked out. And so we're actually now, I'm putting together a grant right now. This is the one that's due on the 23rd, but I'm working with Cineal actually, so that we can roll in colorectal at Queen's and see if we can do something similar with your group. And then we're trying it again in Health Sciences North as well. So going oncology to oncology, neuroncology to neuroncology across institutions, and then oncology to a new disease within the institution, and seeing, okay, if it worked for us, does it work for other people in other places? So I'm excited to see how that goes. Hopefully we get the grant. We'll see.
I think not everyone appreciates how difficult it is to apply an entrepreneurial type mindset within the Canadian healthcare context. Like anyone who's worked in healthcare knows that it is extremely difficult to move the needle on anything.
No, you're 100%. It can take over a year just to get an order set changed on Lumio, right? It really could. And then maybe it doesn't. And maybe after that 1 year, they're like, no, never mind. We're going to keep the way it is. So I think a big part is understanding and appreciating the system that you're in. And you're right. It's a system that is not primed for change. And so our interventions, the ones that we created, had to be created in a way where it did not require the system to change or even the behavior of the individual physicians to change. It simply made things easier for them, right? So in many cases, people didn't even realize that we'd done anything at all. Things were just moving more smoothly.
You have 3 kids. Your husband is a neurosurgeon. Tell me about how you achieve work-life harmony. I never say work-life balance because I think that's a crazy concept and doesn't exist.
Yeah.
But for the rest of the mortals out there who aren't running a company, aren't revamping their hospital system and running a pediatric brain tumor research program, how do you keep all these things afloat?
The biggest thing is just creating high performance teams and then empowering them. I think that's unbelievably important, right? Sarah Belli early on, it took a tremendous amount of my time and energy in the early days. And a lot of my energy for any of the endeavors goes towards finding excellent people to bring on board. Doesn't have to have the longest CV. I actually find that's not an indicator at all of how well the person will perform. They have to have the right attitude, right? They have to be excited, passionate. They have to have grit, probably the most important. And they have to be self-directed problem solvers, right? And so I spend a lot of time identifying those people and then bringing them on board. And then once you bring in excellent people, then you have to trust them to be excellent, right? You have to step back and let them do their job and let them perform the way that, the reason you brought them on was that they'd be high performers, so let them perform. And the consequence of that is that you have this high energy input up front, but eventually gets transferred to these people. And your oversight becomes much more higher order where you're giving feedback here and there. And similarly, when we developed the lab, the thing that I put the most time in, I developed the lab actually like a startup as well, where I created a team of high performing students. And so when last year we interviewed 26 students and we brought on 0 students, right? And so we interview a lot of people and then we find a person not who only is in themselves great and pleasant and hardworking and interesting, but also how does their personality fit into the team of students who are here right now? Because an excellent person, if they're not going to fit well with the team, then the whole lab loses synergy, right? And so we've been lucky to have, we just have incredible, very independent students. And again, that first year of the lab, the first year and a half, took an incredible amount of energy just getting it started up, training them to be, scientists and delving through so many interviews, so many rounds of interviews to find these people. But now that we have these exceptional students, they're training the new incoming students in a big way. And, that being said, Jamie or I, one of us is in the lab every single day. We're actually both here right now. Jamie's hiding in the corner. Most of the day is spent in my office, which is immediately within the lab, working away. And if they have questions, they come in, they ask me a question, I give them an answer. But for every one question that they ask me, they've answered, 50 themselves. And so I think creating those high performance teams is unbelievably important. And then trusting, giving that power to them and trusting them to perform is important. And then I think the last thing is just, it's what you said, is there's no balance, right? And I don't get even caught up on like, oh my gosh, my balance isn't good, right? You just kind of take, one day at a time, one problem at a time. And what I do is when I'm home with my kids, I am absolutely home with my kids. So the phone goes off, it goes into like a little pocket. I'm just with them. And everyone who knows me knows that for these 2 hours, if you try to text me, I'm probably not going to be available and I'll get back to you in 2 hours, right? And if you really need me, then you can call Jamie. But I'll be very, very present. And one thing I've noticed with kids, and I am not the parent you go to emulate parenting, but what's worked for us is it's not so much how much time you have with them. It's the quality of time you spend together. So we have dinner every day together. One of us picks them up from school most days because we find that drive home is when you say, how was your day? What's going on? And they're more likely to divulge when they don't have to look you in the eye. And so that drive, and then we go home and we have a nice time together, and then we eat dinner together every day unless one of us is on call. Then they go to bed. And then frankly, after they go to bed, I work again until midnight, right? And so I probably don't sleep super much compared to most people, but I find I sleep as much as I need. But the time that I do make for them, I just make sure that it is very intensive one-on-one time where I'm helping them with their piano or with their, homework, and then I'm hearing about their day. And then outside of that time is when I get pretty focused and work. But I will also say, just practically, the way that Jamie and my job has ended up. So, being couples matching to neurosurgery and then having to both match to the same grad program where it only takes 6 people a year, like that was very, very hard. Doing co-residency together was very hard. We didn't see each other. But now we're 50-50 surgeon scientists, right? And so literally half our time is in the lab and half our time is in clinical, like doing, clinic, OR, all. And so one of us is usually on research, and that does give that person the flexibility to help with, to do all the kid related stuff. Most days we're still both home on time because the ORs close at 3:30 and they get pretty angry if you're going up. So you can't have to go to ever. And then the other thing is just like huge acknowledgement to Jamie in the sense that we are very, very equal parents. When he is on research, he is the one, waking up and making their lunches and picking them up and helping doing the laundry and, cooking. Well, I cook dinner usually, but he'll keep the house tidy and stuff like that. And so it really is a marriage of partnership and equals. And I feel unbelievably lucky to have that because it wouldn't be possible. And I actually don't think I could do research at all without Jamie there as well. I think the fact that we can tag off to each other, we hand off our patients and then we hand off our grants and stuff like that, is part of what makes it possible. So that is a bit of a unique situation. But I can't, he's a huge reason why either of us can do what we're doing.
Another great team. Thank you again for spending the hour with me. I really, really appreciate it. I've learned so much. I feel inspired and ready to take on the world. So thank you again. One of the questions we always ask all of our guests is if you could go back in time to when you're maybe a chief resident or an early attending, knowing what you know now, what advice would you give yourself?
This is not going to be very profound, but okay. When I was a chief resident, chief resident was really hard. That was one of the hardest years of my life for sure. Also because you write your exam at the end. So I was unbelievably stressed. I lost a ton of weight. I was just not in a good mind frame. And people kept saying, it doesn't get better. Being a staff is just a different type of difficult. I will say, at least for me, it's a hell of a lot better. It's a lot better. There are different stresses. There are different stresses, no doubt, right? And life goes on. But man, I am sleeping more. I am eating more. I am enjoying life more. And so I would just say, do your best, put in the hours, just grind through those chief years, do the absolute best that you can do, find out what you really like. Find out what you're passionate about, what you want your job to look like in the future, not what other people think you should be doing, but what you really want to think, whether that's community or academic or science or whatever it is that you're dreaming of. Try to figure out what actually makes you happy and then just grind through those final years to make yourself the best candidate to get the job that makes you happy and just be very sincere with yourself in what that looks like.
There's light at the end of the tunnel.
There is, at least for me, there was. Yeah.
You've been listening to Cold Steel, the official podcast of the Canadian Journal of Surgery. If you have comments or questions, please email us at podcast.cjs@gmail.com. Thanks for listening.